start. By the way, this is my first presentation on the Web UI community, and I'm here not only to talk and teach, but also to learn from you. That's why I'll be really grateful if you leave your feedback after the event, and so that I know what I need to improve. Today, I want to introduce you to Astro, a relatively new framework that is mainly focused on content-driven websites and promises to make them as performant as possible. A quick disclaimer, this presentation is neither a comparison with other frameworks nor a detailed breakdown of every single feature, otherwise it would take probably 8 hours at least. Instead, it's more of an attempt to spark your interest in Astro so that you can try it out in your own time. Here is our agenda for today, and I really hope that we'll have time to cover all the topics from the list. We'll talk whether performance matters, what is Astro and why, Astro components, pages, layouts and routing, frameworks integration, islands architecture, state management, content layer, and on-demand rendering. Before talking about Astro itself, we need to understand why we even care about the performance of our websites. As developers, we are all used to high-spec devices and fast internet connection, providing smooth experience, even if there are a few megabytes of JavaScript running in the main thread at once. But more often than not, we develop for others rather than for ourselves, and chances are their devices are not as powerful as ours. There are many studies that show how website performance can impact bounce rates, conversion rates, and ultimately your revenue. And still, usually performance is a bit overlooked. Here is a list of a few famous cases. You can find Amazon, Google, eBay, and others in the list. We won't dwell on each case separately. I just wanted to highlight that in a highly competitive niche, the performance of your website might even become a decisive factor of success. A little bit of history. Astro was developed by Fred K. Schatt in 2021. It's a modern open source framework designed to help you build fast, performant, and efficient websites with focus on content. This includes market insights, publish insights, documentation, blog portfolios, etc. The framework is well known for its performance, which is largely hinged on its server-first approach, and it allows you to opt in to client-side rendering only if and exactly as necessary. By contrast, most modern frameworks were designed for building web applications. These frameworks excel at building more complex application-like experiences in the browser, for example, dashboards, inboxes, social networks, and even applications like Figma. However, everything comes with its cost, and with that complexity, they can struggle to provide great performance when delivering your content. With that said, Astro might not be an option for you if you are building something like a highly interactive web application rather than a content-driven website. And despite being relatively young, Astro has already gained great popularity among developers all over the world, and it's still growing. Let me show a few examples of large companies that have already adopted Astro to demonstrate how popular it has become since it was first released 4 years ago. This is the page on their website. As you can see, here we have United Nations Development Program, IKEA, Netlify, Porsche, Cloudflare, what else? Firebase, what else? NordVPN, Stackblitz, etc. And the fact that these companies are using Astro speaks for itself. By the way, if you want to find out if a website is built with Astro, just open the website, open its source code, and search for Astro. Let me show you. So we just search for Astro, and you see that there are a lot of occurrences of this string in their source code. Okay. So let's now see why Astro is something we might want to choose. And please don't panic if some terms sound like gibberish at first. We'll break them down as we go through the presentation. So why Astro? Zero JavaScript by default. The less JavaScript, the faster the website. Islands, independent parts of a website that don't interfere with each other. Opt-in interactivity, hydrate your islands with the client directive only when you need it. content focus, versatile and type-safe content layer, server first, almost all the heavy lifting is offloaded to the server. It's framework agnostic. It means that you can use your favorite UI framework or library with no additional config. Great developer experience, it's ease of development, large numbers of integrations, and supportive community. Server-side rendering support, meaning that you can make your static website a little bit more dynamic. And what's very important is no vendor lock-in. When using server-side rendering, choose any infrastructure you like. It means that you're not tied to Vercel or Netlify or something like that. Now I'd like to talk about the main building block of any front-end framework, namely a component. As any other frameworks, Astro has its own way of creating components. These components have .astro extension and use JSX-like syntax with some modifications and a specific structure. Here you can see a typical Astro component. It consists of two parts, the component script enclosed in 3 hyphens on each side, and the component template right below the script. Let's see what each part is used for. Component script imports other Astro components, imports framework components, imports data, configs, etc., loads content from an API or a database, defines some variables, destructures props for easier access, can hold some sensitive code because it's never shipped to the client, executed during the build process when using static site generation mode, or server-side on demand when using server-side rendering mode. Component template in its turn uses its own template syntax similar to JS6, allows using special Astro directives, responsible for the result in HTML, renders other Astro and framework components, references variables, defines slots, can include plain script text to add some interactivity to your components, and also can include style tags to add styling. An Astro component, as I already said, can define and accept props that you can use in component script or template. Props are available in the component scripts through global Astro object. And when rendering a component, just pass props like you would do in any other framework using HTML attribute syntax. Here is an example of the greeting headline component receiving a greeting prop and a name prop, and below is the greeting card component that renders greeting headline, providing aforementioned props. If you want to pass some inner content to a component, in addition to using props, you can also define slots. The idea of slots is present in any other frameworks in one form or another. It's ng content in Angular, children in React and Solid, slots in Vue and Svelte, etc. So I think that you're familiar with this concept. As you can see, the wrapper component defines a slot in its template, and a component below renders it, providing a block of inner HTML. Anything that goes between the opening and closing tags will appear at the place of this slot. By default, an Astro component has no interactivity and results in a simple chunk of HTML. And if you want your component to be interactive, for example, to react to some user clicks or input, then you just add a vanilla script tag with whatever JavaScript code you need. During the build step, each script tag is automatically bundled with other scripts across the application. And since it's bundled, we can safely import libraries from Node modules, as you can see on the screenshot, write TypeScript code, and use other bundler-specific features. So just to clear up a confusion that might appear between the component script and inline script inside the template, the component script between 3 hyphens is executed during the build time only, can utilize any Node.js API, such as reading files, calling a database, accessing environment variables, and this never shipped to the client, meaning that it's never executed in the user's browser. This section is used to build the initial HTML markup, which is then sent to the user, while the inline script tags are just bundled and eventually executed in the user's browser. It's meant for reacting to user actions, such as button clicks or input changes. Now we'll see an example of an Astro component, how it works in the browser, and how it looks in the code. Let me show it. So here we have a simple Astro component. It's a counter that you can increment, decrement, and reset. Let me show you how it looks in the code. Pages, Astro components. Let me zoom in a bit. So we accept title as a prop just to render in our cart. We also have some initial markup. So this is the value of the counter and three buttons: increment, decrement, reset. And there is a simple piece of JavaScript code that searches these elements in the DOM, adds listeners that you can see here, and executes function, for example, increment, decrement, and reset. And these functions just update the text content of the DOM element. However, to build a website, components are not enough, and we need another layer of abstraction called pages. Astro leverages a routing strategy called file-based routing. Each file in your SRC pages directory becomes an endpoint on your site based on its file path. As a result, any Astro component in that directory can be considered a page. There is a mapping that shows how files are mapped to pages on your website. For example, pages/index.astro becomes the home page. Pages/about.astro becomes the about page. Pages/about/index.astro also becomes the about page, and so on. On the right-hand side, you can see an example of a page. It's just a regular Astro component with a complete HTML structure. Very often, your pages share a lot of common elements, for example, header, sidebar, footer, and to avoid copy-pasting them in each page, we can use layouts. Layouts is nothing but a regular Astro component showing shared elements, accepting props, and rendering page content as a slot. In this example, we can see that my site layout accepts title as a prop and a slot where the content will be injected. The page in its turn imports the layout, renders it, passing the title prop and page content. So the resulting HTML for this page will have everything from the layout, and a slot will be replaced with the content between the opening and the closing tags. Imagine you have a number of products on the website, and does it mean that you need to create a separate page, a separate file for each product? And luckily the answer is no. If you have a set of entities, for example, posts, authors, products, etc., dynamic pages is what you need to generate a page per entity with the exact same layout, only the content is different. So just enclose a file name in square brackets. Let me show you this on the screenshot. Just a second. So you enclose the file name in square brackets and export a get static path function returning an array of objects containing params and optionally props keys. So the ID, the param must match the file name. So if you have ID in the file name segment, you just export this ID in that object. In our example, we will get three pages: docs Clifford, docs Rover, docs Spot, and like so that, and every and you will have three pages with the content for each doc, with doc name, doc breed, and doc age. We'll see a demo a bit later when we cover a section with the content layer. Let's now move to something a bit more interesting, which I really like in the framework. In addition to using Astro components, Astro allows you to integrate your favorite UI framework or a library. And what's more, it requires running a single command, and you can start adding those components to the application. Astro will automatically install all the requisite packages and update all the configs in the project. For example, just run npx astro add react, and you can start rendering React components. In my demos, I've already run this command to save some time, but it won't cause you any troubles. Everything is automated by Astro. Before we get to a demo with a React component, we need to discuss something very important when it comes to frameworks integration. It's island architecture. The general idea of an island is very simple and yet powerful. We render HTML pages on the server and inject placeholders with metadata around highly dynamic regions so that the respective JavaScript can be fetched on the client to hydrate those regions separately. This technique is also known as selective hydrations. In other words, you don't need to hydrate the whole page in one go, but only small regions where interactivity is required. For example, buttons, forms, navigation, etc. In contrast, most modern frameworks render and hydrate an entire page as one large JavaScript application, meaning that your header is not interactive unless image carousel is also fully loaded and hydrated, which of course results in poor page performance. This architectural pattern shifts perspective a bit and makes us think about our pages as small independent islands of interactivity in the ocean of static content. By default, all framework components are rendered statically on the server during the build process, and their JavaScript is not shipped to the client, thus components are not hydrated at all. If we want our components to be interactive, we need to tell Astro how, or rather when we want to hydrate it. In other words, Astro uses opt-in hydration model, providing flexibility and performance improvements. There is a list of client directives that we can apply for this purpose, but for the sake of simplicity, in my examples, you will only find the client load directive, which tells Astro to fetch the components JavaScript and hydrate the DOM element right after the page has loaded. You can explore the other directives in the documentation. And to apply a directive, just add it like an attribute. You can see this on the screenshot. Below is an example of what Astro does with your framework components without a client directive. So it simply renders them during the build process and inserts the output into a static HTML file. So no JavaScript, no functionality, nothing, just a block of raw HTML. However, with the client directive, the result is very different. Astro injects a small script and wraps the component into the Astro Island tag with a list of attributes that dictate how the components must be rendered on the client. The script then looks for these tags, parses their attributes, stores this metadata, and hydrates the components in the right moment. Below is the source code for our example with the client load directive. And on the right, you see what will happen with this source code once it gets built. It's a bit simplified so that we don't get distracted. And as I already said, the script tag is injected to find all the Astro Islands tags on the page and hydrate the elements based on the tag attributes. Let's quickly see what each attribute means. Component URL is a link to component's JavaScript. Renderer URL is a link to framework responsible for this component, for example, a JavaScript chunk with React. Prop is pretty obvious, these are just the initial props passed to the component. And finally client, which tells Astro when it needs to load the component, the renderer, and starts hydrating the respective HTML block. Now let's see it in practice. So we have, on this page, we have two components. These components are the same, exactly the same, but one of them is rendered without client directive, so it's just rendered like this, and the other one is rendered with the client directive. For the first one, no JavaScript has been loaded. It's just a block of static HTML that was generated during the build time. Therefore, no increment, no decrement, no reset button works. But this component was hydrated and its JavaScript was loaded once the page itself has been loaded, and it's fully working component. I'll try to show you this in code as well. Mm, So, so we have a simple React component. I hope that most of you are familiar with React. This component has initial state, has also state for status, which is not hydrated at the beginning. And once use effect is executed, it sets status back to hydrated. And just on this based on this variable status, I add different styling. For those who doesn't know what use effect does, it's just a way to execute some code once the component has been rendered in the browser. So this code is executed after the component has been rendered. That's why we see that the first component has no styling and the second one has styling and functionality. A killer feature of the island architecture is the ability to render components from multiple frameworks in a single page. The only catch here is that you can do that only in .astro files. However, you can pass components as children. For example, a Vue component as a child to a React component. Here is an example of a proper usage where we render two components next to each other. Here is also we pass view counter as a child to React counter, but this one is incorrect. We cannot import a view component directly into a React file and render it. And let's also see how it works in practice. We have our frameworks combination demo, and we have multiple different frameworks rendered on the same page. So, and they are all working as well. So we have Astro itself, Astro component, we have React, we have Vue, and also we have Solid. Let me also see it's in code. It's a different demo called framework combination. So the idea is very simple. Here is a list of our components. I won't go into details, but each component has a counter and functions to update the value of the counter. And we have our page that imports all the components, so React counter, Astro counter, Vue counter, and Solid counter, renders them on the page, applying the client load directive. By the way, you don't need it for Astro because this directive is only meant to use with frameworks such as React, Vue, or Solid. And also another thing is component composition. So as I said, you can pass components as children. So our root component is Astro, which has a children of React and Vue and Solid, and they're all working as well. Let's see it in code also. So the example is exactly like the previous one, but just the markup is a bit changed. So we nest React counter in Astro, Vue in React, and Solid in Vue. And that's the way we achieve this behavior. So far, we've seen a few examples where components have their own isolated state, but very often you will run into a problem of sharing states between different parts of the application. UI frameworks such as React or Vue may encourage using mechanisms like context to share state between components. However, you can't use them in Astro since every component is rendered and hydrated in complete isolation from others. Astro suggests another approach to this problem called nano stores, which allows you to create stores that any component can interact with, including both Astro and framework components. Just install the state manager and an adapter for your framework of choice from npm and enjoy the benefits of it. On the right, you can see an example of installing nano stores and an adapter for React. But these adapters also exist for other frameworks if you use them in your application. Why we choose nano stores and why Astro recommends it in their documentation? Because it's easy to set up. Nano stores doesn't require tons of configuration. It's very lightweight, ships the bare minimum JS less than 1 kilobyte with no dependencies. It's very fast. It's TypeScript friendly, providing full TypeScript support to improve developer experience. And the main feature, it's framework agnostic. This means sharing state between different frameworks will be seamless. The workflow with nano stores is very simple. First, create a new JavaScript TypeScript file for our store. In our case, we use Atom for a primitive Boolean value. And now we can import the store in any file that needs to read or modify the value. Here, cart flyout toggle imports the store, uses a special hook from the NanoStore's React adapter, and whenever the button is clicked, it updates the value to the opposite of the current one. In fact, as I already said, not only do framework components support state sharing using nano stores, but you can also share state with simple Astro components. This is a bit more verbose though, as it requires writing more vanilla JavaScript. Here we manually, let me also use a pen. Here we manually find the open card button, add an event listener on the click event with the open card function as a callback. And once the button is clicked, the value in the store is set to true. Let me also show you an example of state sharing in the browser. So we have our demo. This is very similar to what I've already shown, but this demo synchronizes the value in the store between different frameworks, or rather components. It can be changed from any component. Let's also see it in code quickly. State sharing. So as I already said, we create our store with this simple by calling the atom function, which is meant for primitive values such as booleans, numbers, strings, etc. We have our components that use each uses its own adapter. For example, here I use the adapter for React and use this by passing the counter from the store. Solid in its turn uses its own adapter, its nano stores solid by also passing this object from the store to that adapter. And this is the way how components synchronize their value between each other. I've already mentioned a few times that Astro is a content-focused framework, but haven't said a word about the content itself. Even though Astro can potentially be used to build any sort of application, it was created with the focus on content-driven websites. There are many awesome examples of Astro's power in this realm, from full-featured documentation sites like Cloudflare to beautiful marketing sites for brands such as Porsche and Netlify. And even State of JS itself is built with Astro. Its content layer API is what makes it so powerful when working with any type of content. Regardless of where your data is stored, in local files, your own remote backend, or a third-party CMS, Astro provides a unified, consistent API for all your data collections. What's more, everything is type safe thanks to auto-generated types. There are three key concepts you'll need to grasp while working with the content layer API. It's entry, a single piece of content such as blog post, product, user profile, author, etc. A collection, a set of structurally similar entries. It's akin to a table in a relational database. And a loader, a built-in or a custom method that loads your content collection. Here is an overview of the steps you'll need to take when working with content collections. First, you decide where you store your content. It might be local files or a remote API or CMS. Create some content that you will then publish on the website. Define a collection object in src content config.js with the loader and a schema, and use the methods provided by Astro Content to access and render the content. As you can see on the left, we define a block collection by using the define collection method from Astro content and the built-in glob loader that reads locally stored files and transforms them into JavaScript objects and a schema consisting only of a single title property. On the right, we import the getCollection method and then call it with the collection name as the first argument to get our post, which we then render in the template. So when you execute npm run build command, Astro executes all the loaders in parallel, then caches the results of each loader in a local file, also known as data store. And once it encounters the get entry or get collection methods somewhere in your components or pages, it immediately returns data from that file. Now let's also take a look at the demo that I prepared for this section. It's just a very simple example of a blog that consists of two pages, the main page and the blog page. So you can see the blog page, you can see the home page, and just a list of 6 blogs. Is 6 blog posts. I'll show it in the code as well. So as I said, we first create our content. This is how the content is created by me in this example, but you can also use Markdown files or some remote API. In this case, we use local files, local JSON files, and each file has title, image, description, and body. These are all the same. Also, we have our content config TypeScript file where we define our posts collection. For our loader, we use the built-in glob method. What it does, it looks for all JSON files in src post directory and converts them into JavaScript objects. We also define schema saying what properties every JSON file has. We have title, which is string, body, also string, description string, and image string optional. Thanks to this schema that we define in this options object, Astro generates TypeScript types automatically for us. And we also have pages. So we have our index page. We call the collection by using this name. So we have posts here in the collection, and we use the same name to get collection. By the way, I'll show you, it's also automatically typed by TypeScript. So when you trying to type something, it helps you to choose the right name for the collection. We render every post in a loop by passing the post as a prop to postcard. I'll show you the postcard. Postcard is very simple. It just accepts this post prop and renders the HTML markup for it. So nothing interesting is here. And we also have a page responsible for the blog post itself. We use getStaticPath function that we've already seen while talking about dynamic pages. We also load our posts by using the getCollection method, and we return these posts, or rather special objects with params and props keys. So since our file name has ID as a segment, we also export this ID, or rather return this ID from params object. And also we return props by passing this post. And every page will receive its own version of this post. Like for each of these posts, a separate page will be generated. And here is a markup for this page, basically. Now we are moving on to the last and very important topic of the presentation, on-demand rendering, also known as server-side rendering. As it was already mentioned, when you execute npm run build, by default, Astro will take all of your source files and output static HTML, CSS, and sometimes JavaScript, which are further published to some CDN and served to user. But it's not always what we want, right? Some parts of our application may be personalized. For example, content depends on the user requesting the page, or very frequently updated, which would require rebuilding the whole website for every update. Astro's on-demand rendering solves this problem by allowing us to generate those parts at request time rather than at build time. To enable SSR, we need to install a server adapter depending on the infrastructure that we use for our site. There are dozens of community adapters that you can use, but below is the list of the official ones developed and maintained by Astro's team. If you want to install the adapter, just run the following command and Astro will handle the rest for you. So it will also update all the configs. Basically, it will do everything for you. Once the adapter is in place, you need to tell Astro which pages you want to be rendered statically at build time and which pages must be generated on the fly at request time. This can be achieved by exporting a Boolean value using a constant called pre-render. In this example, we are exporting the false value, telling Astro to ignore this page during the build process and generate it from scratch per each request. Here is how it works from a higher level perspective. We have our server infrastructure. For example, it can be Netlify, Vercel, or even our own web server with Node.js in it. There is also a database or a third-party API. The first client requests the homepage, which is often identical for each user. The server sees that the page was generated at build time and there is a static HTML file, which is immediately returned to the client. The second client requests the profile page, which of course cannot be generated statically as it's different for every user, and the server sees that the page must be generated on the fly, reads some cookies, for example, to distinguish the user from others, makes a request to a database, gets the result, generates that page on the fly, and returns it back to the user. But let's imagine that the home page has something like a tiny user avatar or a name in the header. Does it mean that we lose all the benefits of static generation? And luckily, the answer is no. Astro team has developed a very cool feature for this use case. It's called Server Islands. Server islands allow you to on-demand render dynamic or personalized islands individually without sacrificing the performance of the rest of the page. This means your visitor will see the most important parts of your page sooner and allows your main content to be more aggressively cached, providing even greater performance. To make it work, you need a server adapter from the previous slides and the server defer directive on the Astro component. Keep in mind that this feature only works with Astro components. Let's peek under the hood of server islands. On the left, you can see the source code of a simple page rendering the my server island with the server defer directive. And once you run npm run build, Astro creates a separate endpoint on the website that only returns the HTML content for that particular component. And in addition to that, it generates a static page with a placeholder for the content and a script tag. The script tag makes a request to that endpoint, receives some content in response, and injects into placeholder. So you see in this example of this static HTML page, we have a template tag. And when this page loads, the script tag is executed. It makes a request to get the content of that particular component. It receives that content and just inserts in the DOM by using inner HTML of that placeholder. For the most part, this slide is just a textual representation of the previous one, but I just want to emphasize again that by using server islands, you can aggressively cache the page itself and, for example, host it on some CDN so that your users see the most critical parts of the page instantly and let any personalized parts be fetched and rendered later on the client. Each island is loaded independently from the rest, and this means that a slower island won't delay the rest of your personalized content from being available. And what's really cool about this feature is that it doesn't depend on any server infrastructure and can be deployed anywhere from a simple Node.js server to a serverless provider of your choice. Let's also take a look on the demo. So here we have three pages. It's static page, dynamic page, and a page with server island. As you can see, we have the time when the page was generated, and it never changes because however many times I reload the page, this this text, this date rather, never changes because it was generated once when the site was built. But when we go to the dynamic page, this page is generated on the fly at request time. Therefore, every time I reload the page, this text changes. And the last one is server island, where the page itself is generated at request time, but this component is generated at request time. So as I said, the page is generated at build time, therefore it can be served and statically on some CDN or something like this to be available as fast as possible. And when we reload the page, the content of the date of page generated remains the same, while the time where the component was generated changes with every update. I'll show you this in code as well. So the code here is very simple. We have a bunch of pages. So here is static page that is generated during the build time. So we just get this content once and static HTML page is generated. We also have a dynamic page. As I said, here we export const pre-render false, telling Astro not to pre-render this page during the build time and generate it on the fly at request time. And we also have a page with server island. So it's just a regular Astro component with the server defer directive. And this page is also generated at build time, but this particular component will be refreshed on every page update. And let me show you how the website is built. I also added some console logs to see what console logs are executed during build time and what console logs are executed during request time. So if we build our project, we see only two logs. So static page generated and a page with a server island generated. While when we run the project, let's open the, for example, dynamic page. We see that, let me bring it a bit closer. We see that dynamic page, that the log from the dynamic page was logged to the console. If I refresh the page, it's logged again. And if I open the page with server island, we only get that our Astro component was generated at this time, but we don't log anything from the page itself. So a page with server island is not logged here. To summarize everything that we have covered, let's go through Astro strengths and weaknesses. So speaking of strengths, its performance, Island's architecture, and zero JavaScript by default boost performance significantly. Agnosticism, its ability to embed any framework and run on any infrastructure makes it flexible and easy to adopt. Developer experience, automated scripts, integrations, community templates, and many more dramatically improve developer experience. Search engine optimization, since most of your pages are pre-built, search robots can easily parse the content. Server-side rendering, Astro provides powerful SSR features to make your website more dynamic. And documentation, perfect documentation with clear explanations and variety of examples. And let's move to weaknesses. Community, even though it's growing quickly, the community is not as big as in other more popular frameworks. Dynamicity, may not be the best choice if you're building highly dynamic websites such as dashboards, social networks, etc. Updates requires you to rebuild the website every time some static content changes. Learning curve requires you to learn new syntax, concepts, and approaches. And very niche focus, it prioritizes content-heavy websites, which may limit its appeal for developers building something like highly interactive apps. Okay, that was the end of my speech for today. And guys, I realized that this might have been a bit quick and not super detailed. But as I said at the beginning, the idea was to give you the general overview and spark your curiosity so you can explore the topic further on your own. Now we made it to the FAQ part, and if you're still awake, feel free to ask any questions and I'll be happy to answer them. No questions?
I have one. Have you ever met any problems with module resolutions?
With module resolutions. Yeah, I had a few problems, but they are not directly related to module resolutions, but rather to correct usage of different frameworks. There are some nuances, they are covered in there. I just don't want to go into too much details, but these problems are described in Astro documentations, and by reading that documentation, I understood how to use these frameworks and how modules are resolved. That was like the only problem. Anything else, guys? Okay, if there are any questions left, don't hesitate to text me in Teams and I'll gladly help you with them.
Thank
By
you,
the way,
Volodymyr, for the presentation.
just last sentence.
Okay.
Here is a list of useful links that you can skim through. The last three are repositories from today's demos and that you can pull and run on your own just to explore, to play around with it. And thanks again. That was a pleasure to me.
Thanks again, Volodymyr, for the presentation and for sharing your experience with us. So we hope this presentation was interesting and useful for you, for all of you. So you will receive a feedback form shortly. Please fill it out because your opinion matters for us. And we will be happy to see all of you on next event. So take care of yourself. Bye.
Bye.
Thank you. Bye.
Bye.
Thanks.
Thank you.
Bye.
Bye bye.